Welcome in the fifth and last section in our course. In this section, we'll be troubleshooting real-time processing jobs in Spark Streaming. So in the first video, we will see how to use the sources and sinks in streaming. Next, we will see low latency jobs by understanding batch internals. Next, we will be using data checkpointing to achieve fault tolerance in the streaming jobs. At the end, we will see why Spark introduced yet another API that is called a structured streaming and what are the pros of this API. And this is a first video in which we will be solving the problem of repeating the same code in stream pipeline. We'll be alleviating that problem by using sources and sinks in our streaming processing. In this video, we'll be implementing Spark Streaming Source, so the class that is responsible for fetching data from source to our job, and also Spark Streaming Sink, so class that is responsible for saving our data to some external data store, and we'll be chaining them together. So every streaming job needs to have some kind of a source. We will be building a streaming job that needs to have a dstream of card event. Card event is a sealed trait that can have 3 different instances. So we can get an add to cart event, remove from cart, and abandon cart notification. We need to provide a stream from Kafka in the Spark Streaming API. So we are assuming that we have created a Kafka topic with cart event and we want to consume that data from the Kafka topic. We can use a Kafka utils and create direct stream. We need to specify key and value. Key is a string, value string as well. Then we need to specify a decoder, and also we are using string decoders for key and for value. Next, we need to pass a Spark Streaming context. We will be looking how to create that context in the next video, but this time let's assume that we have a streaming context that is a very similar object to Spark context, but has some additional configuration that are specific to the streaming engine. Next, we are passing a properties that are Kafka properties. So let's see those properties. We need to pass a bootstrap servers. In this example, there will be a localhost Kafka, group ID. So this is an ID for the consumer. If you will want to add another executors in the cluster, if they have the same group ID, Kafka will automatically rebalance those events into multiple executors, and key and value deserializer for our data in the Kafka. Once we have that, we need to deserialize bytes to the specific case class. So we want to deserialize it to cart event. So we are getting a tuple of string and string. Key is a string, value is a string, as we remember. Next, we are reading it using object mapper because our value is a JSON. So we are taking a value and reading it as the cart event using object mapper that is created at the beginning of our sink provider. But every Spark Streaming job needs to have a sink as well. So we need to save results into some data sink. So let's see that code of saving data. Here is our dstream Kafka sink. So our dstream Kafka sink will take a dstream of type T, but type T needs to extend with ID. So we need to have an object that have the ID field. We are doing it because we need to have some kind of a specific key that will be used to send to Kafka to partition our event properly. Next, we are building a properties that are very similar to the customer side. So key, value, serializer, and bootstrap server. Next, we are creating producer of string because we will be saving our value as the JSON, same that we done at the customer side when we fetch the data from Kafka. So we are creating the object mapper, and then there is a trick that is used to make our Spark Streaming job performant because we are using Kafka producer and reusing it using broadcast variable. As you remember from the previous section, when the broadcast variable is used, our object is broadcasted to every executor. So every executor has a copy of the specific producer. So we are creating broadcast variable. Next, we are broadcasting as well topic and object mapper that also will land in the every executor. It will speed up our job because every executor will have their own copy. There will be no need to send that object between executors. Next, for every RDD inside of our result, so result is a dstream and underneath it has an RDD. As I mentioned at the beginning of this video, RDD is used underneath. So for every RDD we are iterating and we have a record that needs to be saved to Kafka. So we are taking a topic and producer from broadcast variables that will be used on the specific executor, and finally we are calling producer.send, creating new producer record from the Kafka API, passing topic, record ID that will be our key that was passed as a partition key to Kafka, and you are writing record to a JSON using object value map. And send also takes a callback as a result because it works asynchronously, so on completion we can do some action if the exception is not null. So if you want to handle failure of saving data to Kafka somehow.